Hello class, welcome to chapter 2. The next video here is about using calculator problems and some examples on how to interpret some tables and so on. So let's get right into it. Here's our first problem. A university is hosting a summer camp for various age groups. The table below shows the relative frequency distribution for the various age groups who have registered for the camp. It is known that 50 individuals have registered for the camp. How many individuals are between the ages of 9 and 11 years old? Okay, so we are given this relative frequency table. So this is basically in the fractional form or in the decimal form, like in this case. So we don't know exactly how many, because we are not given the exact frequency. Instead, we are given the relative frequency. If you recall, relative frequency formula said you took the frequency of that particular class and divided it by the sum of frequencies. So that is what we're trying to find here. We do have some help. We are told that there are 50 individuals totally in this table who are considered who have registered for the camp. So we are asked to find how many individuals are between the ages of 9 and 11 years old. If you look at it correspondingly on the relative frequency column, you see 0.4. So then you have basically the frequency. You're trying to find the frequency of the class 9 to 11 years old, right? Those children. And so for that, you have to get the total number of data values times the relative frequency of that class. It makes sense. I'm not creating a new formula. I'm actually getting it from the frequency, relative frequency formula. Relative frequency says take the frequency and divide it by the sum or the total. So if you wanted so this is basically maths, right? So if you wanted frequency, isolate this by multiplying both sides by sum, and that is what you get here in this formula. Okay, so remember that is the mathematical side of it that you will be called upon to understand and interpret some problems. So here we have the total number of data values given to be 50 individuals. So that is in the problem. So that's 50 times the relative frequency for that particular class corresponds to this 0.4, right? So that's going to be 0.4. Multiply these two and you get 20. So we know that there were, out of the 50 individuals, 20 children or 20 individuals fell in the age group of 9 to 11. And that's your answer. So this is the number of individuals between 9 I'll just write 9 and 11 years old. Okay, so we got so this is a way of interpreting or utilizing a relative frequency table in answering. So you're going to look at different types of problems in your homework to help you understand how to interpret these things, because that's a big deal. Writing this table, computing the table is not a big challenge because we have technology to help us with that. But it's a question of interpreting. And so when you go through the homework problems, you'll also find explanation there. So this is just one type, and you will look at different types of problems with different explanations for that particular question. So let's take a look at the next example here. A researcher gathered data on hours of video games played by 150 students at a school. Given the cumulative frequency table below, what is the percentage of students who play video games less than 6 hours per week? Oh, that's interesting. Less than 6 hours per week. So let's highlight the ones we're given. We're given 150 students there, and we need to find those who spent less than 6 hours per week. So if you look at your table, right, what you have is 0 to less than 2 hours, 2 to less than 4 hours, 4 to 6 hours. So less than 6 hours per week would be all of these, right? And thankfully we have the cumulative table that gives us that information. It corresponds to that value, right? So what we're going to look here is, oops, I gave one more. Okay, to 6, right? Less than 6 hours. So if it's less than 6 hours, you have to compute or add up the frequencies, the relative frequencies for these 3 ones. Okay, so then you have the relative frequencies for these 3. If you add them up, 0.17 plus 0.2 plus 0.33, if you add these 3 from the relative frequency, you will get that equal to the cumulative frequency value here, right? So basically you're trying to find, so let me write that out here, less than 6 hours means 0 to less than 2 hours plus 2 to less than 4 hours plus 4 to less than 6 hours, right? It's because it's broken down, it's partitioned into these 3 classes. You are trying to look at the relative frequency corresponding to these 3 classes. So the relative frequencies add up to 0.7, and that's the reason why we like the cumulative frequency, because you didn't have to individually add them here, because you would have done that part, you'd have taken care of that right in the table when you built and got the 0.7. And so that is how you interpret this. So 0.7 is the sum of the total frequency, but then you have to interpret this, right? So I'll come down here and say 70%, 0.7 converted to percentage. So you always multiply by 100%, right? So 70% of students play video games for less than 6 hours per week. Okay, so that is how sorry, that is how you interpret your answer, because just saying 0.7 does not really make sense to a layperson. So you always try to answer these questions as if you are responding to someone who does not know statistics, because that's the way we will make ourselves very clear. And so it says, what is the percentage? Moreover, that was the question. If you go back here, it says, what is the percentage? So you know that you have to present your answer as a percentage. So you can't leave it as 0.7, which is a decimal representation. You want to give it as a percentage. All right. So now let's look at the next problem, where we're going to use the calculator to build our histogram. A statistician is looking at the number of hits that a baseball player has in each of the past 15 games. Okay, these are the 15 games and the number of hits. Use a calculator to create a histogram to determine the number of games the player has. The player had exactly two hits. Okay. So we have a few things to do. We're going to use the calculator and create a histogram. So use the calculator to create a histogram to determine the number of games the player had exactly 2 hits. Now you can look at this and perhaps figure out, okay, the number of hits is given to us here. So determine the number of games. So how many games did they get the hits? And so we have totally 15 games here. So you can actually look at this and say, oh yes, I can see 2 here, 2 and 2 exact 2 hits. So I know it is 3. Well, again, remember, this is a small data set. This is again to help you understand how to use the calculator. So we didn't give you a huge data set. We will be looking at that as well. But this was just to drive home the point. So don't look at it as an obvious example. It is obvious in this case. But the point here is to help you to see the use of your histogram. Okay, we'll look at more examples, but let's begin with this one. Okay. Now I'm going to list out the steps, but I want you to also understand that I have included resources in our Canvas course for you to look at some other tutorials on how to use the TI-84. The homework problems also kind of lead you through this step by step to know what to do and what keys to punch and how to enter your data. So I'm going to show this to you. You can't see my calculator, so I'm going to try my best to provide the instructions to you, and then you can work with me parallelly to see if that works. So that's the reason why sometimes for some lessons I would allow you to learn the technology side of it by looking at your homework problems and the explanation provided there, as opposed to seeing it in this lecture. So the video lectures are meant to describe and explain and break open the concepts to you, not necessarily work out problems that will help you to look at an exact same problem in your homework. These lectures are not to help you with the homework. These are meant to help you with the concept, and we have plenty of resources to walk you through the calculator instructions that are found already in your homework and other video tutorials. Okay, let's get going now. So this is using TI-84 plus. That's what I have here. So TI-84 plus. So I say this because sometimes the instruction on your in your homework problems would be in general to kind of cover TI-84, TI-83, and so sometimes it may not display exactly the way you see it in the way I'm explaining here. So try to adjust accordingly. All right, first you press the Start button. Okay, and there you have 1, 2, 3, 4, 5, right? You have the Edit, Sort A, Sort D, Clear List, Setup Editor. So that's how you see it, and then you go across from Edit and Calc and Test. You'll be using all these ones, primarily here. But for now, you see that when you click on the Start button, it's already highlighting the Edit part and the 1 part, the first one, right? So all you have to do is simply hit Enter. Okay. So when you hit Enter, it takes you to the table, the columns. Okay. So there you have to enter your data. If you have data already, filled in there, you want to make sure that you clear them all. So for that, you'll have to go to Start again and go down to number 4, which is Clear List, and that will help you to clear the list. Okay. And you have to indicate if it's list 1 or list 2 so that you specify which one is to be cleared. Okay, I'm going to assume that your columns are blank, and so we go to L1, preferably. At least in my example, I'm going to L1, and you will enter these values. 0. You can enter them in any order, meaning you can go by rows or by columns. So it's just easier on my eye to go by columns, so I just do it that way. So go ahead and list them. Okay, so you will enter 0 and then hit Enter, or use the down arrow to move down to the next one, and then 5 and 0. 5, it's not a 0, I'm sorry, it's a 1. 0, 5, 1, then 1, 0, 2, and so on. Okay, however you plan to do it. Remember that there are 15 games, so there are 15 entries here, and what happens is when you enter the 15th value, okay, your calculator shows you at the bottom, it shows L1, and then it says 15 and says it's equal to 0. Okay. That really helps us to see that we've entered 15 entries. We didn't miss out or add too much or add less. So the 15th entry was 0. I always recommend that you go back and cross-check it. Once you have entered the list, go back and cross-check to see if you have your data values entered correctly. Okay. Once that is done, you will use the second. You press the second, which is a blue button in my case, and then use the Y equals button, and that will be the gray button. Okay, so this is blue, this is gray. So we have these two, and then you want to then hit the first one. It's already pointing to, it says Stat Plots, right? And then it says it highlights number 1. Okay, so go to Stat Plot. So the menu already points to the first one. So go to Stat Plot and hit Enter. And what you see there is it says on or off, so you obviously want to turn it on. So this is in plot 1. You're in plot 1, right? So then turn it on. So it's already highlighting to you. If you want to turn it off, you'll move the right arrow key to go to the off button, so you know how to navigate or toggle between the two. So stay on. Then for type, I want you to go to the third one, right? Meaning the graph looks like this. You have all these graph options. So go for the third one and click that one. So you'll have to have the it shows like a dark background when that is selected. And then you have the X list. Okay, the list of X values. It considers these values as X values. So indicate or type there as L1. To get L1, what I did was I used my second button and the 1 key. Okay, because this will be the second plus the 1. Because if you did the second and the 1, you see that the blue key is the highlighted one in the background. Because these are multifunctional keys. One key does many things. So if you just press on the 1 button, it of course types the 1. If you did second and L1, second and 1, it gives you L1. If you did alpha, which is the green button, and green alpha button and the 1, it gives you the green Y. So you always go by the color code to know which button to use in order to toggle between the multifunctional keys, the multiple functions within the key. Then you have this frequency thing. It's already set to a 1. So you got all that. Okay. Once you have all of those, then you want to press the zoom button. Okay. Go to zoom button and click on. So then the next one is zoom. And then go down to number 9, which says, what does it say? Zoom start. Okay, so click on that, and that will give you the. Now it will give you the bars, the histogram. If it doesn't do that, you want to go to Windows, okay, and make sure you set the X min and X max, Y min and Y max to be more appropriate. Like in this case, what I did was I just went by the numbers here. So I went from 0 is the lowest point and a value, and 5 was the highest value. So that's what I did. So I went up to a 6 just in case, because what if it was exactly 5? That kind of covered the window for us. So I went 0 to 6 for X min and X max. So it's 0 to 6. And then the Y min and Y max also I did 0 to 6. What it did for me was when I went to zoom stat, which is zoom number 9, it automatically adjusted the Y window for me, which I didn't do myself. So that really helps you. So you want to make sure that the windows are set for the right values. And then I want you to press graph. Okay. So if you did zoom stat, it takes you to the graph. Okay. But then go to the graph button. These are the gray buttons, okay? And then go to trace button, and it helps you trace. So the moment you click the trace button, the first one it's pointing to you says min 0, max less than 1, and n equals 6. N equals 6 is what you really want to focus on, because that tells you the number of games. So the number of games where the exact hit was, there were exactly 0 hits, was 6. So the number of games where there were 0 hits shows as 6 there, right? Do you see that? So then move your right arrow button so that it takes you to the next bar. It says min equals 1, minimum equals 1, and maximum is less than 2, right? So it's already doing the division for us. It divided it, partitioned the data for us. And there it says n equals 4, okay? So if you come back to our data, you can kind of verify that, right? So we had 4 of the games where we had exactly 1 hit. So then you want to go to min equals 2 to realize that we're looking at the number of games where there was exactly 2 hits, and n equals 3 gives you that. Okay. So we realize that it's n equals 3. So n equals 3 when min is 2, and we're looking at the third bar under the trace. Okay. Now these are details you see in your calculator, but you have to come back and interpret this. So you'll say the number of games in which, so draw the information right from your question, in which the baseball player had exactly 2 hits is 3. We got that information from our histogram. So you got to see how to build a histogram. We're going to look at bigger data and see how we can build it to get our histogram. We call it the grouped data, so we will learn how to do it step by step. Okay, so that will be our next example. Here is a data set. Let's read the question. The data values given below represent the scores for a 10-point quiz in a statistics class. So the maximum number of points would be 10, right? Determine the values of X SCL, X min, and X max needed to construct a histogram of the data set using 5 classes. Okay. Now we saw in the previous example it automatically created because we did not specify how many classes. Now if we have to specify the classes, then how do we use the calculator to help build that requirement into it? And it says for convenience the data values have been ordered from smallest to largest. Now this X SCL, X min, X max, these are all coming from your calculator, right? So I want to kind of show you how it appears, on the histogram itself. So it appears like this, where X min is the minimum or the leftmost value, X max is the rightmost value, and X SCL is basically the class width. So let me kind of point that out to you here. X min would be the leftmost value, and the leftmost value is usually represented by the leftmost bar. Right, meaning that will be your first class, and X max will be the rightmost value, and that's represented by your rightmost bar or the last class. And X SCL stands for the class width for the desired number of classes. So we're going to specify these values in the calculator so that it provides us the histogram with those desired number of classes, so 5 classes. Okay. So let's start with finding the XSCL. That's your class width, isn't it? So class width by formula, we saw that in the other lecture, right? Class width is maximum value from the data set minus minimum value divided by the number of classes. So the maximum value, because it's arranged for us from smallest to largest, it's a lot convenient. So you know the maximum value is 10 and the minimum value is 6.4. Divided by the number of classes is 5 because that's specified in the problem. Okay, 5 classes. And that comes out to be 0.72. Okay. So we want to round it because your data, if you go back to your data has only 1 decimal place, right? So your class width here comes up as 2 decimal places. So we round up to 0.8 so that your class width has 1 decimal place. It just makes it easy to add. This is for convenience, right? and then your that's your XCL, and then X min. So when you actually go to your window in the calculator, right, that's where you'll be entering these values. So it's meant for that. Okay, X min is your minimum value, which is 6.4, and X max is the maximum value, and so that will be now X max you can use the 10.0, right? But 10.0 is matching with one of the values. Now 6.4 is the lowest value, so you can actually set it even to 6, but here X min is 6.4. For X max, we have a small calculation to help us get a better histogram. So the calculation is this: X max is X min plus n times XSCL. Okay, n is the number of classes. Okay, the number of classes. So I call this capital N there. So then X min is 6.4 plus number of classes is 5 times XCL. The class width was 0.8. We do this because we rounded up, right? If you got a 0.72, that would match with your 10.4, but I mean 10.0. So if you are looking at because of the rounded up version, this would give you 10.4 instead of 10.0. You have 10.4, and that is what you will use to put into your calculator. So once you have all those details there, then you would go to the Windows key and edit them. Okay, edit your Windows key and enter these values. If you are provided a specific class, number of classes that they wanted. Otherwise, it will automatically do it for us, and we won't have a way to control the number of classes we want. Okay, so this is an example where we are just using the manual calculations to know what to enter in our calculator. All right. So here comes the next one where we will do all of these and build a histogram. Okay. So here we go. The problem says that the height in inches for a sample of 20 male adults are this. Okay. Use a calculator to construct a histogram for the data using 5 classes. 5 classes are the most popular, reasonable data set we can, the number of classes we usually like to have. So that's part A. Part B says use the histogram to determine the number of men that are at most 70 inches tall. It should be who are at most 70 inches. Alright, so now we have sample of 20 male adults. So you have 20 entries here. And remember that when we punch those in our calculator, we want to make sure that we have 20 of them and always go back to see if you entered the correct numbers. Okay. So let's focus on the first part. It says use a calculator to construct a histogram using 5 classes. Okay. In order to construct a histogram with a specified number of classes, we will need the X min, X max, and XSCL. Okay, so we'll do that, and then the second part is asking us to interpret for a particular scenario. So that's really nice. So let's get started one by one. So here we go. I did edit part B to reflect the problem that I had. So let's focus on part A though. So we will start with XSCL. Okay, XSCL is your class width. Right. So for your class width, you want to go for the maximum value. And again, go ahead and look for the maximum value you have, which will be 82, right? Minus the minimum value, the smallest value we have is 60. Okay. Divided by the number of classes we want. So if you look at the formula itself, you get that comes out to be 22 over 5, which is approximately 4.4. Okay. Now look at your data values. They do not have any decimal values. Therefore, we want to round up to 5. So your class width, we want this to be 5. So Ch2c. Now we have to find x min. That's kind of easy because x min is the minimum value itself, so that's your 60. And we know that for x max we have a formula, so that's x min plus the number of classes times the class width, Ch2c. So then that is your 60 plus 5 times 5. Okay, so 60 plus 25, which is 85. Now we have these three things, and we want to make sure that we will edit, when we edit the list and the window, we will enter these. But don't enter these yet, because I want to show you something which you will discover when you work with me on your calculator alongside. Okay. Alright, so we know that the way we should enter our data into the calculator is using the list, right? So let's get started on that. So we go to the Start button. We went over this in the previous example, so you can always go back to it if you wanted. Anyway, we went to the Start button. Because we used that column L1, I want you to go down to Clear List. So Clear List, which is the fourth option, and then go ahead and hit L1, so that'll, it says done. Okay, when it says done, come back again to Start button, and then hit enter, because it's already pointing to the edit button, so it's in the edit version. So go to edit and then start entering your values in column L1. I'll just say enter values in L1. Okay, and once we do that, we have, again, make sure that you have all the values entered correctly. You should have how many? For that we have to go back to the question, and we see there was a sample of 20 male adults, so you should have 20 entries, and you have 20 of them here. So make sure that you got them all, and then now it's time for you to do the second y equals button, right? And that takes you to the Stat Plot menu. So there you go ahead and turn it on. So you go to plot 1. It's probably set because we just used it in the other example. If you didn't do any problems in between, and if you didn't change it, that's fine. If you did, then go to plot 1, turn it on, and then select the type, the one with the histogram bars. And then your X list will be L1, and your frequency is already set to be 1, so we're good there. Right. It's just is to say that each entry is counted only once. That's what the frequency equals 1 means. Now we might think, well, we have like 60s are repeating, we have 3 of the 60s, so now that is the part that the calculator takes care of. Right now we're entering 63 times, so each time it's repeating only once. That is how we are expressing it to the calculator. So we just enter the list as we see it with the repetitions in it. Okay. Then go to Zoom Stat. Now this is Zoom Stat in Zoom, right? So press the Zoom button, and then, so let me just put that there. Press the Zoom button and go down to number 9, and that's your Zoom Stat. Now what happens is, before you adjust your windows, you will actually have 6 bars, at least in my calculator I could see 6 bars. So and when you go to the Windows button, but we don't want 6 bars, we want 5 bars because we want 5 classes, right? So that is what it does automatically. That's why I didn't want you to edit the window button before you could actually see that effect. So in fact, if you go to the window bar, the window button, if you press the window button, it shows Ch2c as 4.4. Isn't that amazing? Because that's what we got. We got 4.4 as the raw answer, but we rounded it up to 5. and so we increase the class width to 5, and so we want to make sure that those things are replaced here. So go to xmin in your window now and edit it for the values we have: xmin 60, xmax 85, and xscl to be 5. Okay. Now go to the graph. Now click on graph. You get the graph, and then go to trace. So click on the graph button, the trace button. Oh, let me just write about the window quickly. So in window, you'll edit xmin, xmax, and xscl. And then go to graph, and then to trace. But anyway, so the first part is to do the graph, because they wanted us, let's go back here, use a calculator to construct the histogram for the data using 5 classes. So when you do this, your graph should look like this. Now this is an Excel version of the graph, but if you look at a calculator, it should match somewhat with this, right? So because I couldn't show you an image of that, I did this on Excel, but it was a lot of work to get the stuff done in both versions, but I just wanted you to see, I have a visual of this. So you have this, and the bars must touch, of course. See if your graph matches with this. Okay, it should look like that. But when you do the trace, it also shows you minimum 60 to 65, so you can see that this part is 60 to less than 65, right? Because it says maximum is less than 65. So this one is the second bar. So move your trace button in your trace. When you click trace, your cursor is already on the first bar. So move to the second bar, and that says it is from 65, minimum 65 to less than 70, and then 70 to less than 75, and so on, right? So if you looked at the n values, so for the first bar, the n value came up to be 6. The second bar, the n value was of 1. Okay. Now to answer the second part, use the histogram to determine the number of men who are less than 70 inches tall. The number of men who are less than 70 inches tall. So if you come back here, less than 70 inches would be this and this, right? Together, because less than 70 is all of this entire thing. So then it has to be 6 plus 1, which is 7. So it's a cumulative version here, right? So that will be, so we will say the number of men less than 70 inches tall is 7. 6 plus 1. Okay. And so you will look at other variations to these kind of problem types. As always, follow the instructions and you should be good. So this is this covers our histogram problems. Here is an example. Let me read it first and then we'll discuss what we're going to do here. A daycare worker assesses the ages of the children for whom she provides care. There are 14 children in her center and are recorded in the table below. Describe the shape of the distribution and identify notable gaps and outliers. Okay, they didn't tell us to do a histogram and things like that. So I'm going to give you some instructions here. So we're going to do graphing by using the dot plot, the line graph, and the bar graph. Okay. The bar graph is basically your histogram. So I'd like to do these 3 things, and because once we know how to graph them, then to interpret them would be something that you will learn in your homework, so that you are familiar with how to do it on the calculator. So that will be my focus here. Okay. Okay, there are 14 values here. So let's start with the dot plot procedure. Okay. So for this, you have to go into your Start button. Again, I'll try my best to write out those steps or what you will see on the calculator. So Start button. Again, if you have previous listings, clear them, because we need L1 and L2. We need two of these lists to enter, so make sure that it's cleared. Alright, so once you enter stat, you're in the edit mode, so you hit enter. Then you will enter the values here in L1. Okay. Column L1. Enter it as you like. You can go by row or by columns. Okay, so make sure that you have 14 of these entries. Okay. Now the dot plot helps you to, as the name says, you'll be placing dots to indicate how many times a particular value repeated. Okay, so if you look at it, this is again a small data set, so it's easy for us. If it's a large data set, you can see that it's going to be challenging to count how many times 1 repeats. Here we see that 1 repeats 5 times, right? So the dot plot will give you an image of which value repeats the most, which one occurs the most. So it gives us that information quickly. Okay. So we have L1. Now, because your values are all scattered, they're not in any particular order, it helps us to sort this order. Okay. So then we go back to, once you've entered the information, go back to stat, and then if you look at the second option, you have the option that says sort A and open parentheses, right? So that is to sort in the ascending order. Sort D, that is going to be the descending order. So you're going to sort them so that it goes the numerical ascending order. And when you hit enter, you will see that it displays on your screen as sort A, and it opens parentheses like how you see it. So you will have to enter L1. For that you'll have to use second button and number 1 to, and then close parentheses. I've written it in blue so that those are the things you will have to type in. Okay. And then hit enter. So that will give you it will modify your list so that it's in the ascending order, and then go into your stat again. And this time you are going to enter values for L2. Okay. Edit. And then you will go across. Okay, you can use the right navigation button, the right button, the directional button to go to L2. Okay. Once you're there, in fact, if you look at L1, you will see that it has actually arranged them all. So you can see all the ones together. You can see all the 5 ones there, right? Now here is a little tricky part. The way we will enter L2, okay, has to be done this way. So I'm going to write out what you see already. I'll just do it for the first few values. 1, 2, 3, 4, 5. Right? We have 5 of those ones. And 1, 2, 3. We have 6 of those 2s. So 2, 3, 4, 5, 6. Okay, and once I show what happens here, you will follow that pattern for the rest of the numbers. Okay. So this is your L1. In L2, what you have to do is you have 5 of these ones repeating, right? But then you're going to give a unique value for each time it repeats. So for the first one, it repeats only once, right? Because that's the first time you're seeing it. When you look at the second one, you know that you're seeing it for the second time. So you enter number 2. This is the third time, number 3, 4, and 5. Does that make sense? So you're giving a unique value, even though we know it repeats 5 times, you're giving them 1, 2, 3, 4, 5. Then let's go to the 2. 2, you're seeing 2 for the first time because it's in the arranged order. You're seeing it for the first time. This one, you see 2 of them repeating now. 3, 4, 5, and 6. And then you go to the 3. That will be the first time you see it. And then if it repeats, in this case it repeats twice, so you go to the second 3 and then mark 2 for it. Then when you go to the 4, in fact you don't have that many, so I'll just do that also here. 4 only repeats once, and with that we utilize all the 14 values. So you got that. Alright, so now that you have this, it's time for us to go to second y2. Not y2, y equals, second y equals, and go to your stat plot. So go to stat plot, and we want to look at plot number 1. You're free to choose plot 2, plot 3, play with it. I'm just keeping something standard here, so this is how I did it at my end. So I don't feel that you have to always do the plot 1. If your plot 2 is free, you want to do that, go for it. Okay, so here we have to turn it on. By now it's probably on because you didn't have the need to turn it off. Okay, for type, please go to the first one, which shows dots like that, right? It's a scatter plot, so it's scattered. So you want that dot thing, and then your x1, x list is L1, y list is L2. A mark is how you want it to appear. Do you want it to look like a square, a box, or a star? I just choose the first one because it's a little more visible. I choose the box-like ones. Alright, so once you got that, of course you have to do the zoom stat. So go to zoom and go to number 9. The purpose of zoom stat is to fit your data values tightly in the window, right? So it really fits tightly. So you can see now that you have these values all, it looks like this, right? So you have the square, 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 square. Then you have something like this. And so on, okay? So you really can't see much there. So you'll have to click on the trace button, and then you see that your cursor is already blinking at the first box here. So this is where the cursor is blinking, and here it says x equals 1, and then y equals 1 and all that, right? So move your cursor and then it goes up, right? When it goes to this second one, this one here becomes x equals 2. So it tells you where you are. So wherever your cursor blinks, so for instance, if I'll use a different color here, okay? So for instance, if your cursor is in this green spot, okay? If the cursor is in the green spot, you will see that it says x equals 2 because it's in the second one, x equals 2, whatever number you used. If there was no 2 but the second one was instead a 3, then that will show it as 3. So this is x equals 2, you know, 2 repeated 6 times, right? So I have those 6 boxes, you're in the third box, and so it's going to say y equals 3, right? So it gives you those details there. And the box plot really helps you to see how your distribution is spread out. Is it skewed or not? So usually in your zoom stat view, it's pretty tight, so you really can't sometimes see the full spread. So we recommend that you adjust your window. Okay, so go to window, and if you look at your y values there, it's pretty tight in the sense that, you know, your it's just giving what fits in the screen, in the frame. So if you could adjust your y min, okay, I'm trying to do that here, so bear with me here. If you adjust your y min to, let's say, 0, even a negative number is fine, because you really want to see more of the height of these boxes. Because say you had 7 in my screen, if there were 7 boxes, I can't see the 7th box because my height is not able to accommodate that, because some of them may not be going as far or as high as that. So by adjusting your your y-axis, your vertical height, the height of the plot, you can kind of help it. So you see that as it stands, the system for me, it gives me 0.15, and the y max is this is a max. The y max shows what's that, 6.85. So I'm going to readjust this 0.15 to a 0, or you could even have a -1 if you wanted. And then you have your y max. So I want to go a little lower on the y min and a little higher on the y max, right? So I want to, let's make it 9. Okay. So clear your y min and enter. Okay, this is what I'm trying. So I'm going to go with 9. And once you have that, now you go to your graph, you see that you have a better view, right? Meaning you see that there is more room on the top, so that you know that you're not missing any data values. If there were any data values, they would all be lined up because of the equal spacing between them. So you have that, and then go to trace, of course, to trace through your values. So this gives you a better idea, and this is a case where you can see that the distribution, right, it is kind of bell-shaped, but you can see that it's skewed to the right, because this resembles your right foot toe, right? The toes on your right foot, sorry. The values are increasing at the beginning, and then it tapers to the right. So you know that your distribution is skewed to the right. So I'll just say that. Because in fact, if you go back to the question, it says, describe the shape of the distribution and identify if there are any notable gaps or outliers. Okay, so that is the reason why we are investigating that part. So the shape of the distribution is that it is skewed to the right. Okay. Again, if you wanted a better view, I'm going to show you the histogram as well, so that might help you a little more to see that. But in the dot plot, you find that the dots show that the distribution is skewed to the right, and we didn't see much gaps because we had 1, 2, 3, 4 and all that. But the potential outliers, I say potential because I have to investigate some more, and that would require more statistical techniques to decide if there's an outlier or not. But for now, it seems like 3 and 4, those seem to be the outliers because most of the values cluster around 1 and 2. Okay, so this is just based on our observation. Okay, so that is how you get your dot plot. Alright, here's another example. An employer wants to evaluate a team member's absences for 12 months before offering her a promotion and records the data in the table to the right. Create a line graph that illustrates the number of team member absences for the year. Okay. So I hope you understand the background here. So this is for a particular employee, and the employer has this table which has the data related to each month and the number of absences for that month. So we have 1 through 12 months, and then the number of absences that are recorded here. We need to create a line graph. Okay. As the name says, it's going to look like a line, okay, instead of the bars. So how do we do this? Very, very similar to what we've been doing all along. Okay. So once again, you want to go to the Stat button. As always, clear your data. So it's already in the edit. So hit enter. Then you will enter column 1, column L1, which will be your month, and then enter column. Use the right arrow to move over to L2, which will be the absences. Right? Enter these values. It's very, very straightforward. Then you go to the second y equals, and that gives you the stat plot. Then go to plot 1, on. So go to the second one for the type. That looks like that, right? The second one. In fact, you have the last one in the second row, the third one in the second row, that also looks somewhat like that, but no, just do this one. Okay. and then you have the X list, that should be L1, Y list should be L2, and then your mark, it's that square. That's it. Now it's time for us to go into, of course, the zoom stat, and then you go to graph, or you can use the trace button, it depends on your calculator. Then you can trace the points. Anyway, the whole point was to create a line graph. So your line graph would look like this. Okay, make sure it appears like this to you, and it is kind of connecting all the dots basically using lines. So that's the whole idea. And I think I discussed this briefly when we did the histogram. Remember, I connected all the midpoints, and so that gave me a line graph. So that's similar to this one. Okay? A proud mom wants to track the points her daughter scores in her daughter's basketball games. She records the data as illustrated in the table. Use a calculator to create a bar graph representing the number of points scored in the basketball games. Okay, so we want to they want us to create a bar graph. If they specify more details, then we will know exactly how we want to create the bars. But for now, the bars would be drawn using the histogram option that we have. Okay, so that means you may have to adjust the class width and the number of classes. If you are given a desired number of classes, then you'll have to incorporate that, do the xmin, xmax, and xscl in order to adjust it. Okay, for now I'm not going to do that. I'm just going to go by what the calculator presents to me. Now you have these two columns, but you know that we always use just in fact, if you actually go to second y equals and do the plot, when you choose the histogram, the bar graph, the histogram option in the type, you'll see that you only have X list to present. You do not have a Y list, right? So, or you don't have a frequency list. It's always usually set to 1. You can change it to something else, but it's meaningless because we want it to occur only once. So this data, what I'm going to do is I'm going to rewrite this data. Even though it is summarized for us, unfortunately I have to undo this and write it as a single list. So we know that the daughter scored 6 points in 2 games, right? So that means the 6 repeats. Use a different color. So 6 repeats twice. Then 8 repeats 4 times. 10 5 times. And 12 4 times. This is very helpful when you have to go in and enter in your list 1. Okay, so as always, now you know the drill, so I'm not going to repeat it each time, but I'm going to just say it verbally. Okay, so go to stat, make sure you clear the list, and once you clear the list, go to stat and hit the edit button, and then go to L1, and in L1 you're going to enter 6, then go down, enter another 6, then enter 8, 8, 8, 8, 10, 10, 10, 10, 10, 5 of those, and 12, 12, 12, 12. Okay, and at the end of it, you want to make sure that you have entered 15 values. Okay, how do I know that there should be 15 values? Just quickly add this, because they didn't give that in the instruction. So add these two. So 2 plus 4 plus 5 plus 4, right? That is 15. So there were totally 15 games, and so we are talking about the 15 games listed out individually and the number of scores. Because of the way the table was set up, it naturally lines up as in ascending order. Okay, smallest to the highest, which is fine. Anyway, so now it's time for us to go to second y equals. Okay, second y equals, and that gives me the stat plot. Go to stat plot, and then go turn it on. The type is to set it for the histogram, the 3 bars. 4 bars, what you see. It's a third option basically. Then your x1, enter L1 as your list, and frequency is 1. Now go to zoom, and then go to zoom stat, and then you have your bar, And I'm just going to try and attempt to draw this for you. So my bar, because I did not specify, I did not edit the Ch2c, it looks like this. There's this one bar here, and then there's another one, there's a gap, and then there's a taller one, the gap, and there's another one. Stretch this a little bit. Okay. In fact, if I moved my cursor in the trace area, because this is from the graph, click on trace, and that will give you the cursor there. The cursor shows that this is n equals 2, and when I move the next cursor, it gives me minimum 7.2 to less than 8.4. Okay, so now we don't have those decimals, so unfortunately this is how mine shows. It shows this as 4, then there is a gap, so there is a 0 here, and this one is given as 5, and again 0, and this would be 4, right? So if you see, if you add all these bars, it does add up to 15, but what's really I should say, I don't know, it sounds silly here, is that your minimum value is 6, and then it goes all the way to 7.2. So it's anything less than 7.2 is in the first bar. So 7.2, and then you have 8.4. So that's because it divided it, accordingly, because I did not specify any class. So if I want to specify class, then I would have to make those changes in the window option. Okay. And the maximum value was 12, so it went up to 13.2. So we do have the minimum and the maximum. But again, as I mentioned, adjust the window so that you get the corresponding bars adjusted to reflect what you want to see as whole numbers instead of these decimal partitions. All right. So play with it. Enjoy, explore. That's the way to learn. Don't be afraid to make mistakes when you're learning. Okay? So that's how we learn. And if you come across other kinds of problems, feel free to go explore all the resources that are provided to you in the course. We have the TI-84 online resources in Canvas. We do, of course, have your homework problems that come with the explanation and the steps to what to do on your calculator. And it gives you an interpretation of your answers as well, if you wanted to learn more. So please go ahead and make use of all the resources. And we are officially done with Chapter 2, and I will see you in the next video for Chapter 3. See ya!